Welcome to Chemistry News. Today we're going to talk about the chemical reactions and how they are involved in the global warming. Today we have the topics of the carbon cycle, and we're going to explain that. We have the main chemical reactions that are involved in the carbon cycle, how has increased the carbon dioxide in these years, the effects of the increasing of carbon dioxide, the chemical reactions that are involved in the global warming, and we're going to tell you a reflection of this.
Carbon cycle. The carbon cycle is a biochemical cycle by which carbon is exchanged among the biosphere, mesosphere, hydrosphere, hydrosphere, and atmosphere of the Earth. Plants use carbon dioxide and sunlight to make their own food and grow. The carbon becomes part of the plants. The plants that die are made into fossil fuels made of carbon like coal and oil over millions of years. When humans burn fossil fuels, most of the carbon quickly enters the atmosphere as carbon dioxide. Then this carbon dioxide is consumed by animals. The carbon present in the food made by green plants reaches animals through the food chain. Carnivorous animals receive this carbon when they eat other animals. Respiration by plants and animals. Carbon dioxide is regularly being returned to the atmosphere by a process of respiration in plants and animals. Burning of wood and fossil fuels in industries and automobiles also release carbon dioxide.
There are many chemical reactions that are involved in the carbon cycle. Anything from giving birth, breathing, dying, lighting a match involves carbon is able to significantly impact life on Earth. One chemical reaction we are all familiar with is cellular respiration, in which oxygen is used to break down carbohydrates, with which then results to energy, carbon dioxide, and water. Carbon dioxide is also released in various exothermic reactions. Some natural, some synthetic. Natural reactions include volcanic eruptions, forest fires, and volcanic vents. Synthetic reactions include burning of fossil fuels, gasoline, and coal. Another chemical reaction is called photosynthesis. Through this process, plants use solar energy to turn atmospheric carbon dioxide into carbohydrates, sugars. Organisms use the carbohydrates through the process of respiration, mentioned above.
In 2009, the carbon dioxide global average concentration in Earth's atmosphere was about 0.387%, but now the northern hemisphere dominates the annual cycle of carbon dioxide concentration because it has much greater land area and plant biomass than the southern hemisphere. Concentration peaking may bring up begins and reach minimum in October when the quantity of biomass undergoing photosynthesis is greatest.
Based on our previous information, we can infer that we, the human race, have interfered with CO2's natural cycle, and we have boosted its production, resulting in damaging the atmosphere with various air pollutants as well as greenhouse gases. We, as a human race, must understand that our interference is killing the planet itself, and as a result, killing us. We must stop our excessive use of CO2 and production of it, because that is the only way that we can survive as a race.
Hi, I will talk about the causes and effects of carbon dioxide in the atmosphere. The concentration of carbon dioxide in Earth's atmosphere has reached 391 parts per million. Carbon dioxide is used in photosynthesis and is also a prominent greenhouse gas. By burning fossil fuels for the past 200 years and by cutting down forests, man has increased the levels of carbon dioxide into the air. This has damaged the normal carbon cycle, which keeps the temperature steady, and the extra carbon dioxide is causing an enhanced greenhouse effect, which is making the planet gradually warmer globally. Since the magnitude of human release and atmospheric rise are comparable, and the atmospheric rise has occurred contemporaneously with the increase in production of carbon dioxide from human activities since the Industrial Revolution. Atmospheric carbon dioxide levels have increased substantially during the past century and are expected to continue to do so. The emission of gases into the atmospheric generates irreversible damage to the ozone layer and contributes significantly to the rise in global temperatures.
Now we're going to talk about the reactions that are involved in the global warming. First, ozone is an equilibrium in the ozone layer, forming a decompose due to UV radiation. Radicals of chlorine are catalyzed via a chain reaction leading to ozone depletion. They are very efficient in the decomposition of ozone, since they are not consuming the reaction but is recycled and may return to actin. The decomposition of chlorofluorocarbons after successive reactions leads to obtain radicals, chlorine, which react with nitrogen dioxide and form chlorine nitrate or nitrogen monoxide, and methane to form hydrochloric acid. And the reaction hydrochloric acid also chlorine nitrate with nitric acid. Hydrochloric acid and chlorine nitrate compounds are quite stable and do not react with ozone. Only under specific conditions are captable or producing reactive radicals, which are the cause of the ozone hole.
Okay, so after doing this project, we as a team have gained a further understanding of how CO2 works, how it affects us, and how we affect it, as well as how it covers the entire world and how it is responsible for global warming just as we are responsible for it. Our strategy towards fighting global warming is to stop deforestation by any means necessary, reduce the use of industries, cars, and other air pollutants that just increase the amount of CO2 in the air and therefore create even more global warming. As a conclusion, we would like to thank our instructor for giving us the chance of doing this project, of gaining more knowledge about CO2, knowing how it is risky to us, and in consequence we are to the planet.